We're going to invite a colleague of Elena's, Guillermo Grau, who is also at Lobelia Earth, tech lead, and we're going to talk about front-end tools. Here he is. Thank you.
Thank you. Okay, so our next presentation, so I guess this is the one. Our next presentation is about the main tools that are available to users for accessing and exploring the Copernicus marine data. I'm going to be talking about MyOcean, which is the web portal, and then my colleague Renaud will give you an update on the toolbox, which is for programmatic access. Okay, so MyOcean has been or is evolving in multiple directions. And I'm going to be talking about two prototypes or two proofs of concept that we believe are the most interesting ones. The first one is a 3D digital globe. This one will be the default view for MyOcean Lite, which is the web portal aimed at beginner-level users. We believe that the 3D will not only be nice, but it will also make it more intuitive. Here, for example, it's very straightforward to see the Antarctic circumpolar current. And in this other video, I think it's very easy to grasp the vastness of the Pacific Sea in a way that really is hard, if not impossible, to do with a flat 2D map. To me personally, this looks like a scene from another planet, but it's in fact, it's Copernicus data. It's a salinity variable from the global physics model. So we also have another video. Is it like this? Yeah. So 3D will be just another view, as I said, like polar projections or equatorial projections. You will have the same tools as in 2D. So, for example, you will be able to get time series, vertical profiles just as easily and quickly as in 2D. Thanks to the data that my colleague Elena was mentioning, the ARCO data in the Marine Data Store. So what you're seeing here is 4 different locations across the Pacific. And the video has not been accelerated. So this is the performance you can get. Then 3D will also be available on Pro, on MyOcean Pro. But in this case, you will have more freedom about how you place the camera, how you orient the camera so that you can, in fact, see terrain. By terrain, I mean orography, the mountains, the bathymetry, and how this terrain relates to the data that you're visualizing. So in this particular scene, you're seeing the Alps at the right. You are seeing in the center the valley of the Rhone River in France. And we are comparing visually the chlorophyll levels at 3 different points, 3 different distances from the mouth of the river. So 3D helps understand those values, put them in context, and we believe it will be an interesting addition, not only visually, but also really useful. Okay, the second prototype or proof of concept I wanted to share is unsurprisingly about AI. So these days, today and in the coming days, you are going to be seeing agents in all sorts of shapes and colors. For us, the question was what would happen if we integrated an AI agent with a viewer, and we did it so tightly that the agent could even control the viewer. So this is something that we have not seen yet out there. So I will show you some videos. But before that, I would like to ask you not to look too much at the UI, because it will be much nicer in the future. This is a preview, and this is only to demonstrate the capabilities that are enabled by such an integration, not so much about the UI itself. So please bear with me. Then another side note is that the agent runs on the cloud. It's not running in your browser, it runs on the cloud. But it has knowledge about what the viewer can do and what the state of the viewer is. So it can choose to use those tools. And you will see that maybe it's a bit fuzzy now, but you will see it in the videos themselves. So, okay, so this is the first video. The user is asking the agent what is the salinity and chlorophyll northeast of Ibiza. the agent knows that it can move the map, that it can place a pin, that it can read the values, and then, since it's relevant to the question, it does that. So it reads the values and gives a nice table and gives some interpretation even of the results. So it says salinity is relatively high compared to the Atlantic, for example. Then in a second example, we're going to ask the agent something that we know is wrong. Because agents have a tendency, they don't like contradicting users, and they would rather hallucinate an answer before saying, no, you're wrong. So this is what we do in the next example. We say, is it true that salinity decreases as you move in the Mediterranean Sea from west to east? So obviously, the opposite is true, and the agent knows that it is that this sentence is wrong, but we were surprised by how it reacted. Instead of saying you're wrong, it proved it, and it proved it with the Copernicus data. So it placed some pins in the Med Sea basin, left to right, and we were just cleaning the pins up a bit, but it read the values for those pins and then explained. So actually, it's the opposite. Here, the agent is explaining what it's doing. Then it creates a table with the values left to right, where you can already see that the trend is the opposite. And then it explains. And what it says is that, yeah, okay, so in the west you have more water coming from the Atlantic, and in the east you have more evaporation. Okay, I'm not going to explain this to a room full of oceanographers, but this is what is happening here. So you already see that the user experience is very different from just using a chatbot or just using a viewer. It's this tight integration that is enabling something new and something I find quite amazing. Then finally, we ask, is that also true in summer? So it will, maybe you don't see it from the back, but it's changing the time step to July. Reading back the values and basically saying the trend is robust, it holds all year long, so you can, again, another table. So this is one way you can use the tool. You can interact with the chatbot and let it manipulate the viewer, but you can also do it the other way around. You can act directly on the viewer and ask the agent to interpret what you're seeing. And this is what we do in the next example. So here, the user has placed pins manually on 3 different basins, on the Atlantic, on the Med Sea, and on the Black Sea, and is asking why is salinity so different at these locations. So the agent reads the values, again coming from the Copernicus data set, and explains them a bit. So in the open ocean, you have a reference, an intermediate value of 35. Then if you go to the Med Sea, since it's a semi-enclosed basin, it's a bit higher. There's also more evaporation. And then in the Black Sea, let's wait a bit. In the Black Sea, you have a much lower level because of river inflows, limited exchange with the Med Sea, and so on. So something that is maybe easy for you, but for some intermediate users or beginner users that are just facing for the first time this data, it's nice to have this interpretation at hand. So these are the 2 prototypes I wanted to share with you today. The full-featured 3D digital globe, which is going to ship very soon. And this new MyOcean peer or data copilot, so we really don't have a name for it yet. So if you have any ideas, come to us. And then these are only the headlines. We have shipped to production or are developing multiple different features like dashboards, radar, multi-forecasts, well, you see many of them here, multilingual support, user data upload. If you see something here that catches your eye and want to know more about it, please come and see us at the coffee break, and we can give you more details or even a demo if you want. So, and now I leave you with my colleague, Renaud.
There he is.
Good morning. I'm Renaud Jester from Lobelia. I'm a developer, so I'm the main developer on the Copernicus Marine Toolbox. I'm sorry in advance because it's not going to be as beautiful as Guy's presentation because it's a Python library. But I'll try to make it interactive anyway. How is this? Okay. So what is the Copernicus Marine Toolbox for the ones that doesn't know in the room? It's a Python library. So it's actually the programmatic access into the Copernicus Marine services. It's important to notice that it's open source. So there's a public repository on GitHub that you can go check. We have documentation also built with it. And it's distributed through the classic Python channels. Now, maybe you wonder if actually a low-level Python library without AI is actually used. Well, a little bit. So Elena presented some numbers, but since January 2025, we have 20 petabytes of data downloaded just with the toolbox. 4 million download requests, around 20,000 users, and it's right now we're at 120,000 installation per month with 1,500 daily users and around 1,000 operational users. What you can notice here on the graph that I showed, two things. First is the increase in usage. I think it's also the increase in usage of the Copernicus Marine service, so it's a good sign. And the toolbox is a good access through it. And the second thing you could notice, because here in this graph you have the green part that is the access with the toolbox to the native data, and in blue is the access of the toolbox to the ARCO data, so the subset that we presented before. So it's interesting to see that they're actually increasing the usage also of this ARCO data, because I think it's a very interesting feature for users. This ARCO data, as it allows you to select better the data, go faster, and it's a very nice format. So yeah, the conclusion a bit of this usage is that it's not MyOcean, the toolbox, but those are just two different entries to the Copernicus Marine service for different users. So the toolbox is a bit more operational users. So users that we regularly download or integrate the Copernicus Marine data in their pipelines. About what happened since January 2025, we really focused, also listening to users, on robustness. So one example is that we have twice as less releases in 2025 to increase stability and also have backward compatibility in the releases to help users with their pipeline, with their uploads, and that it's a seamless experience. Then we had new features, so I'm going to present just a few of them, a few important ones. One of them was the in situ and satellite dataset subsetting. So these basically datasets that are not gridded, so it was kind of a challenge. And for example, I made a little example here where I select the sea temperature in the Copenhagen Bay with the in situ data, and I use the toolbox. I don't have much knowledge about the platforms or how this data is measured, but I can have the data since 1990 and have a graph of the temperature. This is a graph of the yearly temperature in this area. Another example is, another big feature we released is the subsetting with the stereographic data. So you can access in ARCO data directly from the toolbox this data in stereographic projection. And lastly, one feature that we think can help the users with their pipelines also is this split on common. So we keep improving the functionalities. For the future, first thing, we'll keep working on robustness. It's still very much of an objective, also performance, also stability, so this is in our head. And then for new features, we have many ideas. One of them could be the plotting functionality of the toolbox to help you visualize what you downloaded. Also, maybe if you're in an environment where you don't have access to many Python packages, you can use the toolbox directly to see the data. We want to improve the catalog exploration because some users report that it can be a bit difficult to choose. For example, you want sea temperature, which dataset do you use? So these kind of things directly integrated in the toolbox. And finally, we will follow the Copernicus Marine Service evolutions. So if there's new data sets, new type of data, new challenges, the toolbox is here to evolve and keep following the evolutions. And I think that's it. Thank you.
Thank you very much, Renaud. Thank you very much.